All right, let's look at the fixed point of a transformation. All right, so here's the definition. Point A in a plane is called the fixed point of a transformation f if you apply f transformation, you're going to get exactly the same point. So that's why it's called the fixed point, because the location is fixed. It doesn't go anywhere. It just stays the same. All right, so let's look at an example where we need to find a fixed point of a given transformation. All right, so here's the given transformation, and we want to find the fixed point. All right, so what we need to do is we need to make sure that the x prime is equal to x, and a y prime is equal to y. All right, so we can see that here. So this we have this equation. So x is going to be the same as x prime. So you have a 2x plus y plus 1. Right? Since we want to get f of x comma y equaling x comma y, right? So x prime is x and y prime is y, right? So we have these equations. Y is equal to x plus y minus 2, right? So we just need to solve this equation. I like the second equation better. So you can see that you have a y on the left and a y on the right as well. So by subtracting y, we can just scratch that out. So we have this is going to be 0. So we know that here we can simply add 2 to both sides. So you see that x equals 2. So we got x is equaling 2. All right, so once you have that, then we can just plug this guy into the first equation. So this is going to be equal to, so I'm going to plug x equals 2 into, maybe I'm going to go around this way, right? So here and also here, right? So we have this equation, so x is now 2, right? And 2 times 2 is 4 plus y plus 1. Right, so we can simply subtract 5 from both sides. So you can see that 2 minus 5 is negative 3. And here 4 and 1 cancel out, so y is equal to negative 3. Right, so therefore the fixed point would be x is 2 and y is negative 3. Right, so this is the fixed point. Right, maybe I'll box it in. All right, so it's pretty easy. And for this problem, we have a single fixed point, but you might end up having a whole line of fixed points, and or the whole plane. So in this particular problem, we have a single fixed point, but we could possibly have infinitely many fixed points. All right, and just a quick definition of an identity map. So if every single point happens to be a fixed point, we call that transformation identity map or identity mapping. So you can see that for all x in the point P, I of x is always equal to the same x, right? Then it's called the identity map, right? So every single point is a fixed point, then the transformation is called the identity map. All right, that's it. I hope that this was clear.